Okay, we're going to continue our talks about triangles, and today we're going to look at a special segment inside the triangle. So that special segment is called a mid-segment of a triangle. A mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. Segment that connects the midpoints of two sides of a triangle. Segment that connects the midpoints of two sides of a triangle. So get out your straight edge if you don't already have it out, and go ahead and draw a triangle. And it can look however you would like it to. There's my triangle that I'm putting up on the board. So I'm going to label my triangle ABC. We'll call it triangle ABC. So here's A, here's B, and here's C. So a mid-segment is where I take the midpoint of AB, and in this case I'm just going to eyeball it today. We could construct it, or we could do some measuring there. But there's roughly the midpoint. So that means I know that here and here are the same distance. And so between A and B, I'm going to call that point D. And then I'm going to do the same thing on side AC, and I'm going to call that point E. So that I know it's not necessarily the same distance unless we have the same side lengths, but if those are different side lengths, then we need a second tick there to show that. So the mid-segment is the segment that goes from D to E. So I'm going to draw that in, the segment going from D to E. We're going to learn about that mid-segment in just a minute, so I'm going to come back to this picture. The next thing you have is the mid-segment theorem, and so we're going to add to this once we talk about this mid-segment theorem. It says the segment connecting the midpoints of two sides of a triangle is blank to the third side and is blank as long as that side. So what I noticed from that picture and what you should see in this picture is that it looks like they're going the same direction. Those two sides are going the same direction. So the mid-segment is parallel to the third side. Another cool thing about the mid-segment then is that it's half as long as that third side. So if I go back to this picture, I can see that DE is parallel to BC. Another really cool thing, though, is if it's half the length of BC, then if I found the midpoint from B to C, and again, I'm just kind of eyeballing there, I'll call it point F. Let's put 3 tick marks there. So if DE is half of BC, then it should be the same length as BF or as FC. So then here's another thing that we can look at. I could draw another mid-segment from point E down to point F. And when I do that, the third side, there's AB. So it should be the same length as half of AB and get a single tick mark. I can also draw another mid-segment from D to F, and it should be the same length as half of that third side. So it gets another tick mark. Now if you look, we formed 4 triangles within that triangle. You'll notice that each of those triangles has a single tick, a double tick, and a triple tick. So we formed 4 congruent triangles just by forming those 3 different mid-segments. So I think that's pretty cool there. Okay, so how are we going to use this mid-segment theorem? If you look, it says MP is a mid-segment of triangle LNO. Find the value of x. So looking at the first example, we want to know the length of MP. If we know that NO is 16, well, the midsegment is half as much, so then we know that X would be 8 here. If you look at example 2, MP is a length of 7. We need to find the length of NO, and in this case, we would need to double it to get X, and it would be 14. Don't get tricked by example 3. We're not looking at the midsegment there. We're looking at the sides, and don't forget, when we have a midsegment, that it's from the midpoint, so those two pieces are the same. So in this case, X is 4. A lot of students will put down 8, but it really is the same length there. And then in example 4, we would say that X is 9 because it's double the length of that midsegment. Okay, so that's all we have for 5.1 notes. So you are all set to go. I will see you in class. If you have questions, please come in and see me.